It's tiny, and most of the time the technology doesn't work. All right, so we're starting out with trig, and we're going to review some basic stuff. The first thing talks about radians to degrees, degrees to radians. I don't know if you even remember what a radian is, some of you. A radian is another way to measure an angle. What it really means is, well, let me talk about it this way. If you have a circle, hello, please work. If you have a circle and you take the radius of that circle and then you were to lay that same distance around this way, so those are equivalent lengths. Everybody with me? This length is equivalent to this length. Does that look about right? Maybe? Okay. That would be a radian. The amount of turn that was in here would be 1 radian. Okay? So it's 1 radius is what it is in arc length. So if we did another one of those here, I used to do this with string and it worked out pretty well. And I did another one of those here, you would start on the 4th one and there'd be a little bit left over here because it takes exactly how many to get around radians? Anybody remember? 2 pi, does that sound familiar? So 2 pi is equal to 360 degrees, which to make life easier, we usually think of it as 1 pi is equal to 180 degrees, okay? So that's how our conversion is. So I don't ever memorize anything if I don't have to. So I don't know, do you multiply by pi over 180 or 180 over pi? I just use dimensional analysis. Does that make sense? If I have radians, then I need the radians to cancel, so I put the pi on the bottom. If I have degrees, I need the degrees to cancel, I put the degrees on the bottom. Okay. So, real quick. Oh, are we supposed to write those down? Okay. If you want to write something down, if you had radians and you wanted to get rid of it, you would multiply by 180 over pi so that the radians would cancel and you would get degrees. If you had degrees and you wanted to get radians, you would put the 180 on the bottom so that the degrees would cancel and you'd end up with radians. Now, radians do not have to be in terms of pi. Let me say that again. Radians do not have to be in terms of pi. Those are the most common ones that we use, the special right triangles and the quadrantal angles. We leave them in terms of pi because they're exact. But I could say 12 radians. It doesn't have to be 12 pi radians. Does everyone see what I'm talking about? 12 radians would be about 4, right? 4 pi, somewhere around there? Okay. So it'd be around 2 circles. Okay. Convert. So real quick, this is degrees. I need to get rid of degrees, so I'm going to put that down here, this on the top. Then that's supposed to be a degrees right there, not a multiply. Oop. Yeah, now it looks like 1800. Way to go, Hoffbauer. Sometimes it's the technology and sometimes it's the teacher. Okay, still looks like a dot. Then if you're like me and you hate reducing fractions, you can go 375 divided by 180, math, enter, enter. Or there is another way to do that. If you are using mine, is it alpha y equals? Yes. Alpha y equals, and then it's choice 1, and you could type 375 over 180. And then I think when you hit enter without doing the whole math enter enter thing, it would reduce it. Okay, so if that's new to you, welcome to my world. Okay, so what did we end up with? 25/12? But we didn't type the pi in on purpose because it would have changed it to a decimal. So we have to leave the pi as part of our answer, or we'll get it wrong. The same with the negative on this one, guys. You have to leave the negative. Eventually, you're going to have this one memorized. 45, 90, and 45 more. This is 135 degrees. 45 would be 1/4 of the way to pi. So this is pi over 4, 2 pi over 4, 3 pi over 4 is going to be here. We're going to develop the unit circle real soon, and you're going to have a memorization quiz already on Friday. So, yes, negative 3 pi over 4. Everybody good? You could have done it the same way I did number 2. Okay, number 3, you're going the other way. You want to know my trick? Pi is equal to 180, right? So I usually just cross that out and write 180. What's 180 divided by 3? Okay. You really did dimensional analysis because you multiplied by 180 over pi to get to degrees. But if you just cross it out and replace it, it's the same thing. So on here, you could type negative 103 times 180 divided by 18 on your calculator. Replace the pi with a 180, but I'll do it the way that. So it's 180. I want to get rid of the pi radians. This actually goes in here 10 times, so I'm thinking it's negative 1030. Did someone get that on their calculator? Okay. Haley, you awake? Did you just have trig or this semester? No. Oh, so you need to be awake. Candy's coming around. Sugar up, guys. I know I did not sleep last night either, so I get it. Me too. Negative 103. I wrote 180 over pi. Then I canceled the pi's. And because I was doing it in my head, I did 18 goes into 180 10 times. And then I did negative 103 times 10. But you could have typed the whole thing in your calculator too. Negative 103, I would have just done times 180 over 18. Okay? Because the pi is divide out. You good? All right. Coterminal. Does anybody know what coterminal means? Co means together. Like cohabitate, cooperate, all those words, okay? And terminal means ends, in this case. Okay? So they end in the same spot. So 180 is equal to pi radians. Those are coterminal, right? They end in the same spot. They really are the same angle. But I could also call that 540. Does that sound right? If I went around, do you remember which way positive goes, guys? Yes, we start from here. The initial ray is always the positive x-axis. And it goes this way. If I went all the way around once and to here, that would be called 540 degrees. I think I added that right. Okay. So 540 is coterminal with 180. Make sense? There are also negative names. So I could go this way and call this negative 180 degrees. Or I could go all the way around again and call it negative 540. Anything that ends together. So how do you find angles that are coterminal? If you are in degrees, you want to know another name for that ends at the same spot, you would do what? Yes, add or subtract. How much? 360, a whole rotation. So if it is in radians, you will add or subtract, what's one rotation? 2 pi, okay? When it asks for all the angles that are coterminal, it gets a little weird. If it wants all, then you say n. I use n, 2 pi, yes. The book sometimes uses k, I think, I don't know. where you say n is any integer, so any positive or negative number, and then if your answer was in degrees, like 70 degrees, and you wanted all the ones that are going to stop at that same spot, you'd say I could add or subtract 360 n times. Because n is an integer, it's got to be a whole number of times. Does that make sense? The book will just say plus, because integers themselves can be negative, right? So they're trying to save themselves a little, but I always write plus or minus in my brain that reminds me that I could be going either way to find the same spot. If it happened to be a radians question, like pi over 6, you would put plus or minus what? 2 pi, and then the n, meaning infinite rotations could happen. That only means if it's asking for all of the names. If it just wants one, just add it once or twice. There's really infinite right answers when it asks for a coterminal one. If you want to save my brain, you just add 1 or subtract 1, okay? Don't get crazy, because then I have to try to figure out if you're right. All right, so find a positive and negative. Which one do you want to do? We don't need to do both of these. Pick one. The negative one? Okay, so we need another negative name and another positive name for this spot. Okay, so negative 405 to begin with would be where? If you add 360 to that, what do you get? Negative 45? Okay, so it's down here in this quadrant, right? Everybody get what I'm talking about? Went all the way around in another negative 45 degrees. So could this be a really good other name for a coterminal spot? Okay, how do we make a positive name then? Add another 360. You could have subtracted and put negative, what, 765?
Looks like it.
Something like that, but is it 315, guys? Okay, so there's a negative and a positive name. I just skipped 7 because I think you all know how to add and subtract 360. Are we good? Okay, and what do we do if it's in terms of pi? Add and subtract 2 pi. Do you want to do 10 or 9? 9? Okay. So subtract 2 pi. Now, there's a couple options. You could type 5/3 minus 2 on your calculator and do a math enter, enter. Okay. I personally would like you to get good at fractions. It's very important in this trig unit. What is 2 if you have to have a denominator of 3? Multiply by 3 over 3 and you get 6/3, right? So I have 5 pi over 3 plus or minus 6 pi over 3, because this is equal to 2 pi. So if I add it, I get what? 11/3. You add the top and keep the bottom, right? If you subtract, 5 minus 6 would be negative 1/3. If you did 5/3 minus 2, math enter, enter, did you get negative 1/3? Okay. And then if you had done plus, you would have got 11/3. Questions? Does this feel too tricky? I hope it's coming back to you. All right. The next thing we're going to review super fast is right triangle trig. This is that good old SOHCAHTOA stuff, remember? Okay. We're going to use sine, cosine, or tangent. We're going to decide, is sine going to help us, cosine, or tangent? Now, the thing you need to know is this only works when you have what? Right triangle. Only works when you have a right triangle. So, if we don't have a right triangle, then we're going to learn a whole new bunch of stuff. But for today, we're talking sine, cosine, and tangent. So what happens is you're going to be given 2 pieces of information. With those 2 pieces, you can find all of the rest and solve the whole triangle as needed. So in this picture, they give us the distance away from the wall and a ladder, the length of the ladder, and they want to find the angle up here. Now, when you're finding an angle, you have to do undo, right? You have to do second Sine, cosine, or tangent? Does that sound familiar to anybody? Okay. This particular one, it says, from this angle we're trying to find, we're looking for the opposite, and we know the opposite side and the hypotenuse. Opposite and hypotenuse are OH, so they go with sine. And because you're trying to find an angle, you would do second sine. Now, in this case, it's an application, so you would want to be in degree mode. So on your calculator, you would do second sine, and it was actually 2.5 over 5, wasn't it, guys? Like that. Now, I am not in degrees. It should say at the top if you're in degrees or radians. Otherwise, you have to go to mode. Should be 30 degrees. How we doing? Just check that one so you know that you're in degrees. Everybody good? Any questions about how you type that? That was second and then sine because these were both lengths and we wanted to find an angle. All right. It undoes. Second sine is called the inverse sine, and it means you're finding the degree of angle. Okay. All right. Back to our notes. Let's just write out what these mean again. The sine of an angle is opposite over hypotenuse. The cosine of an angle is adjacent over hypotenuse. And the tangent of an angle is opposite over adjacent. Some teachers teach Oscar had a handful of apples. Has anybody ever heard that one? That's Oscar had a handful of apples, gives you those in that order. And they're always in that order on your calculator. Do you see that? It always goes sine, cosine, tangent. Okay. What? Oh, yes. He's a creepy little guy up there. All right. And then, okay. When you have to find an angle, then you work backwards. So what we did on that one was inverse. Was it inverse sine? Okay. So to find an angle, we did sine -1 of opposite over hypotenuse. Okay. Before we go any further, where are these opposite adjacent words coming from? Okay. So we have to decide which angle we're talking about. I don't know if you remember Greek letters. That guy's theta. Alpha, maybe? Lowercase alpha, I think. So if we're going up here, okay, from this one up here, this is opposite, right? But if I was talking about this angle, then this would be opposite. So it matters where you're talking about. From this one, that's opposite, this is adjacent. Why can this guy never be adjacent to anything? It's across from the 90, it's a hypotenuse. We're all good with all that stuff, right? Because if you struggle with that, everything's going to be a mess from here on out. Okay, pick one. Which one do you want to do? Okay, 12. From angle theta up here, this would be an adjacent leg. This would be the hypotenuse. We're supposed to find the measure of the angle. What uses A and H? So we have the cosine of some angle equals adjacent over hypotenuse, which we type in our calculator as inverse cosine. It doesn't say I'm going to go with degrees unless it tells us otherwise. Inverse cosine, what was it, guys? I already forgot. 2 divided by 3.6, like that. 56.3, yes. Please round carefully to the nearest tenth, it says. Okay? Now on the next section, yes. An angle, yes, 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 yes. Perfect. These have angles, acute angles given, so we're not going to need to do inverse on these. Great question. Okay. So 14 or 15, guys? Let's do 14, maybe, and 15. I don't know. Are we on 1B now? Okay, this is page 1B. All right, so from the angle we're given, I always draw a little smiley face down there. It helps my little directed study students. This is the angle we're working from. Okay, opposite of that angle is over here, because it's all the way across the triangle. Across from the 90 is the hypotenuse. Which one uses O and H? So katoa, so we need sine, and then it's the angle we already know, 64, equals opposite over hypotenuse. Now, got to be real careful. I always tell students set this up like a proportion. So when you cross multiply, 25.6 gets multiplied by 1, right? And then we're going to divide by the sine of 64 to get the x by itself. Everybody good with what I'm talking about? Cross multiply and divide. Do I need to write out another step, or are we okay? So 25.6 divided by sine of 64. Did I remember the right numbers or not? 28.5. Did anybody else get that? So this side we came up with 28.5. Reasonable or not? It had to be what? Bigger than 25.6, so be careful. Now, on this one, if I put my smiley face up here at B, because that's the 40-degree angle they gave us, we could find the one at A, but let's just go with this. Opposite is over here. This is adjacent. Now, what uses O and A? So the tangent of 40 equals 3.6 over x. So again, I'm doing what? Yeah, 3.6 times 1 is 3.6. And then I need to divide by the tangent of 40. It's not always dividing. What does this one come out? Anybody got an answer for me? Anybody agreeing with 4.3? Is that reasonable? Could you figure out whether it had to be more or less than 3.6? Do you remember how that goes? Little geometry hint. If this is a 40 and this is a 90, the triangle has to add up to 180. So this angle down here is a 50, right? And across from the 40 was this number. Across from the 50 needs to be a number a little bit bigger than that, right? Somehow bigger than that. Okay, because the smallest angle is across from the smallest side and so forth. All right, let's do one more. Let's do 16. Call it a day on these. Oh, this is actually a 30, 60, 90, but this is the angle we're working from. This is adjacent. This is hypotenuse. What function would that be? So the cosine of 60 equals x over 17. Adjacent over hypotenuse. This time, when we cross multiply, we just get 1x equals 17 times the cosine of 60. The cosine of 60 is something you're going to have memorized. Okay. If you type this in, let's see, let me review the 30, 60, 90s. We're going to do this eventually, but 30, 60, 90, this is twice as long as the short leg, and this one is x squared roots of 3. So cosine from 60 would be adjacent over hypotenuse, would be x over 2x, or 1/2. So this is 17 times 1/2, or 8.5. Did someone get that? Okay. We're going to memorize the 30, 60, 90 patterns eventually. All right. Next thing we get to review, does everybody remember hearing about these before? Cosecant, secant, and cotangent? Okay. I don't know that you have these. Do you need to write these down? When you flip sine over, it becomes cosecant. I remember that because C doesn't go with C, it goes with S. Okay? Sine flips over and becomes cosecant, whereas cosine flips over and becomes secant. You see what I'm saying? The C1 goes with the S1 and the S1 goes with the C1. And then tangent and cotangent sound like they are right. Pretty got whatever they want, not quite.
Oh, no, that's just.
Well, we all know where the numbers are supposed to be.
Yes, thank goodness. Some of you don't even know how to read that kind of clock anyway.
I still do.
I know how to read that. I just can't cursive very well.
Oh, I can't cursive?
Can't cursive very well. I am capable. It just
All right.
looks like
Are we good on the notes here? Okay. This one wants the value of the trig function, and that means exact as a fraction. So if we need that third missing side, we're going to have to do what? It wasn't this class. There's one class I always said when we needed to do quadratic formula, I always said Pythagorean theorem. So now I'll say quadratic formula, okay? We need to do Pythagorean theorem possibly to find that other side. Cotangent, you need to memorize these, okay? Tangent was TOA, so cotangent flips that over, and cotangent becomes adjacent over opposite. So do I know the adjacent to this angle down here? Okay, no, I do not. I need to find this side. Now, this is a missing leg. The other leg is 6. So you'd have 6 squared plus that missing leg squared equals 10 squared. I never actually write these out. I just subtract them on my calculator. 10 squared minus 6 squared. And then you square root it. And we don't have to worry about plus or minus, right? Because it's a length. Anybody have that one memorized? 3, 4, 5 is a right triangle. The 5 has to be on the hypotenuse, right? Does that sound familiar to everybody? It's called a Pythagorean triple. What does that have to do with this problem? It was 6 and 10, so this is 8 because it's multiplied by 2. It also works if you multiply by 3, so 3 times 12, 3 times 5. Everybody good? Yes. Okay, now, we didn't finish this question. The cotangent, now that we found this side is 8, cotangent is adjacent over opposite, so it is 8 over 6 or 4/3. Now, this did not ask us to find the angle, guys. Too often students do this question wrong on their homework because they find the angle. It only wants the value of the trig function. So the answer is 4/3. You don't type second, tangent, something, or whatever. Do we have to do Pythagorean theorem on the next one too? Cosecant is the flip of what, guys? Sine. So sine is SOA, right? So OH. So this one should be hypotenuse over opposite. Yep, I think we got to do Pythagorean theorem. This is a nice one, I think. This is a leg again, so 24 squared plus x squared equals 25 squared. If you subtract 25 squared minus 24 squared, I think you get 49. Anybody helping me? So this is 7. Doesn't look like a 7. So hypotenuse over that 7 would be 25 over 7 is the cosecant of the angle. I don't want to know what the angle is, guys. I just want to know the value of the function. Make sure you're answering what they asked for. Everybody okay? Some of them, they don't give you a picture. You have to draw a picture or not. On 22, maybe we should do 21 too, I don't know. 21, tangent is opposite over adjacent, right? So I need this side right here. So I have x squared plus what? 18 squared equals 9 square roots of 5 squared. Some of you are going to have trouble with that on your calculator. You have to be real careful if you're going to do that on your calculator. But what's 9 squared, guys? 81. And the square root of 5 squared should just be 5. So this should be 81 times 5, which sounds like 405 to me. And then if I subtract 18 squared, 324 minus 4, is it 81? So x is 9. All right, so then what's the tangent? Tangent is opposite over adjacent. 18 over 9, which is 2, right? Everybody okay? Got to work from that place that they gave us with theta. Now 22, they're trying to trick us. What's the relationship between cosine and secant? So the cosine just becomes 5 over 13. Nice try. We're too smart for them. Oh. But sometimes they don't give us a picture and we do have to do some work. Like number 24 right here, that's a hot mess. Are secant and cotangent related at all? So how can we deal with that? Draw ourselves a little triangle, put theta wherever you want at one of the acute angles, yes?
You could find the hypotenuse by squaring 11 and squaring 5 and
Why? Explain to me why that works. Yes, these are opposite and adjacent. Yep. I was just going to draw the picture so that that's clear, but if you can just do it from memory, yes. It's not opposite and adjacent, though. It's adjacent and opposite, right? Because it's cotangent. So this is adjacent and this is opposite. So adjacent and opposite. But he's absolutely right. If you knew what that was, you could find the hypotenuse that way without ever drawing it. Square this is 11, square that is 25. Is 36, which is the hypotenuse squared. So this is 6. Yes? Now, what does it want? It wants secant. You just got to be careful where you're working from. So secant is the flip of cosine, and cosine is ca, right? Adjacent over hypotenuse. So we need to flip that. Hypotenuse would be 6 over adjacent, but it's adjacent to where we drew it. So or if you labeled it over here, it was this A. So 6 over square root of 11. The evil mathematician says we cannot have a square root on the bottom. We have to multiply by square root of 11 over square root of 11, which makes this 6 square roots of 11 over plain old 11. Everybody good? Because secant or square root of 11 times square root of 11 is 11. We good? Okay. Next page. Does the next page look like this? Oh. I probably could have saved you a little time because there's the notes you just took about flipping them over, right? It was good for you to write it down. Helps you memorize it. All right, it says if you're missing one side, you have to do Pythagorean theorem. So they did Pythagorean theorem. This was a disgusting 3 square roots of 26. And then it said find all 6 of them. Okay. Ugh. Yeah, let's skip that and try this one. It's bad enough, I think, on this one. All right, we got to do Pythagorean theorem. 10 squared plus 5 squared sounds to me like 125. Square root of 125 would be 25 times 5, I think, which is 5 square roots of 5. If you're not good at simplifying, you need to get good. Okay, everybody all right? Now, I always do them in that order, sine, cosine, and tangent. But, guys, think carefully because some of these are going to have to be rationalized. But we don't want to have to rationalize them twice, meaning get rid of that denominator twice. So, the next 3, the reciprocals are cosecant, remember that's the flip of sine, secant, it's the flip of cosine, and cotangent, which sounds like it goes with tangent, and it does. All right. Is sine going to be nice, guys? Sine is opposite over hypotenuse. From this spot down here, let me get my marker. Little smiley face down here. This is going to be opposite, adjacent, hypotenuse. Is opposite over hypotenuse going to be nice? No, but what about the reciprocal? This one would be 5 square roots of 5 over 10. Does that simplify? The 5 and 10 can reduce because they're not in a radical. So it would reduce to square root of 5 over 2. Everybody okay with that one? Okay, sine we are going to have to rationalize. I'm going to do my work down here. The sine is 10 over 5 square roots of 5. Can we simplify first? Can I just divide those? This becomes a 1 and this becomes a 2, right? So I have 2 over square root of 5, and then what do I have to do? That icky rationalize step. So I get 2 square roots of 5 over 5. Okay, cosine is adjacent over hypotenuse. It's 5 over 5 square roots of 5. What happens there? Oh, wait, yeah, that's right. Okay, sorry. No. Yes, it's 1 over the square root of 5, which when you rationalize becomes square root of 5 over 5. Now, this is why I don't want to have to flip it over again. Think about what it started out as. Yes, well, secant is hypotenuse over adjacent. So it's 5 square roots of 5 over 5, which will just become what? Square root of 5. Everybody good with that? Okay, are these easier? I hope. Tangent opposite over adjacent, which would be 2. And cotangent is adjacent over opposite, which would be 1/2. I didn't mess up, did I? We good? All right. Oh, this one I'm skipping. Deal? Okay, let's go to 3. What time are we done today? Okay. We'll try one more. Number 3 says use the given one to find the other two. So you could say this is opposite and hypotenuse and work from there. I always draw the triangle because it helps me. So I've decided where I'm going to put my angle, and then I have 3 and 7, and my triangle's not drawn proportionally, I can tell already, but it doesn't matter. Okay. How do I find this side? 3 squared plus some missing side leg is 7 squared. Isn't that 49 minus 9 is 40, guys? Square root of 4 times square root of 10. 2 square roots of 10, right? Someone else get that? Okay, then I get to label them, because that would help me this moment. This one is opposite, this is hypotenuse, and this is adjacent. You can use these identities if you have them memorized, but I would much rather draw. I always draw. Okay, so we have to find the rest of them. We got sine. What's cosine? See if we can get this done. Cosine would be adjacent over hypotenuse, right? Tangent, anybody tell me tangent? Opposite over adjacent. What is that going to become? Three square roots of 10 over 20. Can't read that, huh? Okay, we got to flip them all over real fast and then we're done for the day. What's the flip of sine called? Cosecant would be 7/3. Secant is going to be 7 over 2 square roots of 10. 7 square roots of 10 over 20. And cotangent, we don't want to flip over that messy one, but remember right back here it was 3 over this, or it's adjacent over opposite, so it's 2 square roots of 10 over 3. All right. So your assignment, and I cannot stress enough that this is not going to go well if you do not do work. Now, all of the book work is in your packet. Thank you, Ms. Hoffbauer.
Yeah.
Even the problems are circled, okay? So you need to do this assignment. I think they're circled even on the worksheet, aren't they? On worksheet 3A, B, 4A, which we did not get to the application problems. I don't know where that is. I don't know. Is 4A applications? No? Okay. 4B, you can, if you start with the word, if you get to word problems, you can leave them and we'll work on them tomorrow, okay? But page 227 that is on 4B, I think you can start some of those. Is the first one maybe is the only one that's not a word problem? All right.